Hi, this is Andrew Darkangelis, ABE 205 VBA programming project. And today I'm going to be showing you my program that I wrote. So the first worksheet that you see looks pretty plain, pretty generic, but what it's going to do is output specific information that the user is going to enter. So when I press this button, Run Simple Growth Model, this user form is going to pop up. So it asks for several different bits of information that the user will fill out. So this program would be used for a researcher or scientist who is interested in finding the population of a culture at a specific time. So here, the researcher would enter in his or her name. They would enter in the starting population of whatever they're trying to culture. So we can say it's 300, that's fine. And then they would enter in their growth rate that they would find experimentally using a differential equation. They would enter in what population is going to be measured. So here I'm going to say that we're going to be measuring mesenchyme stem cell population. Here is predicted growth, so this is what they think it would be after this specific time in this time unit. So we're going to say after a day, this is 24 hours, so after a day, we're just going to guess. Maybe it's 200 million. And going back to this growth rate, they are going to be using the exponential growth rate law, which is the population equals your initial population times e to the power of your rate constant times your time. So, and here we have the culturing type. So this combo box displays the three most common types of cultures. So obviously this is a cell culture. Then this combo box is where the user will select their growth medium that they're using. So we're just going to say it's a nutrient media, because that's what would most likely be used if you're growing cells. And these checkboxes can be checked so the user can keep track of what ingredients or contents were in their growth medium. So we'll just say it's probably these, maybe some amino acids, some carbohydrates. And when the user presses accept, it shows what would be entered, and all of this is what we entered in the user form right here. So welcome Andrew, your initial population is this, your growth rate, your predicted population, and it lists everything. Then it also shows the equation that you're running your numbers through, and this is the growth rate law that we'll be using in this program. So this is how many stem cells we'll get after this amount of time. And if it's a lot of if it's a lot of yield, so I have it set up to where if the user's starting population is less than 500 and their ending population is greater than 50 million, I believe it is, it will output sounds like you need a bigger petri dish. So we'll click OK, and now when you press accept and save, it will output the information into the worksheet, just as we saw it in the message box. And then obviously if we were to press the cancel button, it would close the user form without doing anything. So here in this worksheet, it looks really complicated. A lot's going on here, so I'll run through it, break it down for you. So this first button that says run graph when we click this user form will pop up, and it will ask for the number of rates, your time step that you're going to be incrementing by, the unit of time, the final time that it's going to increment to, and the user starting population. Now this part of the program would be useful to a researcher who wanted to measure and compare different rates. So they might be using a different type of growth medium with different contents in it, and find different rate constants for those different types of medium. Then they might want to compare those and see what type of values they would get for that. So we're going to have it compare. This is where the user would enter in his or her different rates, and I have 7 different rates in here. So let's just say we want to compare the first 3, and we're going to increment it by 10, and it's going to be in minutes, and we're going to increment it all the way to 1500 minutes, and then we're going to say our starting population is 300. So if I were to press cancel, it would do nothing, and if I press save and graph, it outputs the data in the graph, as you can see, and it outputs the data in these columns. So you have your time versus population, as you can see, incremented to, by 10 all the way to 1500, and it only did it for the first 3 rates like we told it, and all of these values are population values. So for at time equals 10 minutes using rate 1, which we defined was 0.012, this would be the population. And you can see it changed it. I don't know if you noticed, time was in hours before because of a previous measurement made, but it changed it to minutes in these parentheses so the user can keep track of their units. So right here, this graph, it should display all 3 of them next to each other, but the range is like just looking really wacky. So the user would hopefully have enough common sense to format the axes, and who knows, maybe let's try times 10 to the 10th. Whoops, and something wacky happened. So we'll undo it. But if it were working correctly, it would auto set it so you could see all 3 curves very nicely. So it is displaying the other 2 curves with rate 2 and rate 3. Or I should say rate 1 and rate 2 are down here. We can't see them. And this is rate 3, as we can see. So then you have a button to show or hide. Maybe the user has like 10 different rates. The graph would be blocking it, so they would just press hide so then they could see their different rates. So now this button says find time at selected population. So what this is for, if we click on it, it says find when function reaches a specific population. So this would be if the user wanted to know at what time will there be this many cells in the culture. So I have in 50 million. So yeah, so let's see when for each rate the population will be 50 million. So if I press save and accept, this dialog box pops up and it says time when population is 50 million when using this as rate is 1010, and that would be for rate 1, and then it does it for rate 2 and rate 3 because that's what we specified it. as. That's what we specified it to do. So, or wait, let's try that again. Yeah, so we only specified it to do these three because of our previous, the previous part of the program that we ran. So it spit out the numbers in these cells. So we wanted to know when it would reach 50 million, and so when using this as the rate constant, it will be at 1,100. When using this as the rate constant, it will be 760, and when using this, it will be 610. So let's scroll down and see if that's not right. So sure enough, this value, really between both of these values, it found it, but it's set up to where it will say the time when it's equal or greater than, and it's the immediate value. So that's at 1,010 minutes. And then using the second rate constant, it should be at 760 minutes. So if we scroll down, sure enough, that's where it crosses over 50 million. And then for the last rate, at 610. So right here, in between both of these, it steps over and reaches 50 million. So it would tell the user at this time. So this could be useful for a researcher who wanted to compare different rate constants and to see what would be most efficient, because they might want to yield a specific value of cells or bacteria in a certain amount of time. So we're going to step into my code really fast, just show a few things going on. So if we step in to the first user form, if you remembered what that did, that was the user data that the user would keep, where they would keep track of their data with. So this is all pretty easy stuff to understand. These are just simple if-then statements to output the data. Most of this stuff is just to output the data into the worksheet. And then in here, we actually run, in lines 12, we actually run the equation, the exponential growth rate law, and it outputs it. Then here's my if and then statement that will display, sounds like you need a bigger petri dish if that's the case, or if the program thinks that's the case. So yeah, all this does is output the data. And then down here, this just initializes so the user kind of has an idea of what they're going to be doing. So if we step into our second user form, this was for the graphing bit of the program. So what's important here is this for next loop. And what this does is it runs the equation for all of the different rates in those, for all the specific times. So you can see that here with this equation. And then the rest of this code just outputs the data into the worksheet. And once again, we have some initial values put in, so the user kind of has an idea. And then the last user form, very simple, kind of a long code though. So what's important here is the for next loops that read the columns of data of the rates. So this for next loop will read this column, this for next loop will read this column, and so on. And I have that up to a definite value because I'm assuming that the user isn't going to be comparing like 30 rates at once, because that would be really ridiculous if anybody ever wanted to do that. So I think I have it up to 10, so we'll do it for the first 10 rates. And then this code is just to display it in the message box. This code is to display the information in the worksheet, and also it depends on what they name their rate. It will also display the name of that, and then the initial. And then in here, it's just load or unload the user forms. And then here we have our buttons to activate and deactivate the graph. So, so as you can see, this meets 8 of the 11 requirements in the grading rubric. I actually didn't show this, but I have this in an array. I don't know if we can see that or not, but this is used in an array to read the data. And obviously I have subroutines, because nothing in VBA would do anything if we didn't have subroutines. My 4 next loops are critical for the program to work, as you wouldn't generate any populations for any times without the loops. And the graph activates, like you saw, this graph activates when you enter the information in the user form. And also I had many if-then statements, conditional statements. Some are more trivial than others. So I don't have any in there. But here's some if and then statements. So that's my VBA programming project. Thank you very much for your time.